Hi everyone, I'm super excited to invite our speaker, Prasanna Padmanabhan, Netflix Machine Learning Platform Director, who's going to share their story of how Netflix built their machine learning infrastructure.
Thanks, Gideon. I'm excited to be here. As Gideon said, my name is Prasanna. I lead the ML platform teams within Netflix. So excited to be here and happy to see you, everybody here.
So, thank you again. Maybe start if you can share a little bit about kind of your journey into engineering in general, machine learning. What brought you to that? What did you do before? Yeah.
All right. A pretty deep question to start with. Maybe a soul-searching way of identifying this. Where do I start? Look, as everybody here in this room, as a kid growing up, I still vividly remember the first time I had my hands on a computer, and I was like really fascinated by the power that this or the magic that computer brings in. But over a period of time, I think I was pretty intrigued by data specifically, the patterns that you see in data, the decisions that you can make with analyzing data. I think is super powerful. And so I did my master's in with database specialization, and then Yahoo really, when I joined Yahoo, it really started helping understand how do you build large-scale distributed systems. And with the advent of things like Spark, you really make data engineering super easy for everybody to try and analyze things. So if I combine things like distributed systems and data infrastructure and things, that's where I started to get into ML data infrastructure, and then slowly moved into things like training side of things with the advent of PyTorch and TensorFlows, which makes it easier for anyone to try out things on training. So maybe the short answer for that is I think it's all about data that got me excited about coming into the field of machine learning.
That's amazing. So maybe I know you've been at Netflix for almost 10 years now, right? I know a lot of us, I spoke to people before, a lot of us use and watch Netflix a lot. Can you share a little bit on a high level, what are some of the projects that Netflix utilize ML for?
Look, ML is practiced in many different places at Netflix. We internally call something called pitch to play. And what I mean by that is from the time when our creatives come to us with a pitch to the time where we greenlight that pitch, get into identifying the casting, doing things like shooting the actual video, whether it's TV series or movie, doing things like pre-production, and then finally doing things like post-production and stuff, and then it comes to the service. And what you all have been well familiar with is personalization, which is at the very end of, the product is there for you to watch and things, and then there's lots of things we do in personalization. But ML is also used in many different places, right from what we call from pitch to play. We build models to do things like content demand understanding. What I mean by that again is if we greenlight a particular show, how much members will watch that particular show. And that's a good signal for our creatives to decide if we should greenlight a show. And then even during content creation, we started to leverage machine learning for creating content. Again, not at the way of replacing our creatives, but leveraging machine learning for making our creatives be more creative, and so that they can focus more on creative tasks and less on mundane tasks.
So I think obviously like there's a lot of use cases, and I'm assuming there's more stuff on the business side as well. But I know when we last spoke, we talked about kind of these two key focus areas for your team or your internal customers: personalization, right? And then content generation, which at first I think might be surprising for some people, especially with your philosophy of not trying to replace the creator, but really try to assist them. So maybe we can cover both of these areas and then kind of jump into a little bit more media engineering stuff. But so on the personalization side, curious, maybe if you can describe a little bit like what kind of models do you guys use, of course, the level you feel comfortable sharing, and then how do you measure these models post production? How do you make sure that what is the North Star metric that you guys are optimizing for?
Yeah, look, our North Star vision for personalization is you folks go to your home, switch on your TVs, and your absolute best content for that is already started playing for you, right? That's our vision. Are we there? We are nowhere close to that, right? Show of hands, how many people, watch Netflix or try to watch Netflix and then spend like, I don't know, 10, 15 minutes and you get tired of identifying which one to see. So there you go. So there's lots of work that we need to do in personalization. One of the favorite quotes from Reed Hastings, our CEO, is that we suck where we are today compared to where we will be in the next several months to days to years. And I think we are doing well in certain areas in personalization, but not that great in many areas of personalization as well. But making sure that we are able to recommend the right title to the right member at the right device at the right time is super critical for our business. And how do we measure that is if I look at some business metrics, how many hours did our members stream Netflix? It's a good indication of are they really enjoying the content. As a subscription company, do members retain is another key business metric that we look at to see if our members are enjoying the show, enjoying various content that we have within Netflix. But in terms of models, look, again, there are a slew of machine learning models that power the Netflix homepage. There are models that figure out what videos to show within a row. There are models that figure out what rows to show to our members in the first place. There are models to figure out which artwork should we show for a given member in a video combination. So, for example, you and I may like Stranger Things, but the artwork that we show for that could be different based on our taste and things like that. Search is also a recommendation, but we also think search is a failure in homepage recommendation, right? Like, why do you want to go for search when you don't see the videos that we are recommending in the homepage? So these are all the different types of models that we leverage within personalization. But again, it's a bread and butter. We say choosing is a very critical component of Netflix business, and personalization models helps our members choose the right content as fast as possible. But as you can see here, I think our work will be done when next time if I come and ask people, they're like, no, it's not that much. We're able to choose videos much faster.
That's super, super exciting. And I know the other area we talked about that I think is like very exciting, especially like as you know, I think the industry very excited. Some would say a little bit hyped around generative models. So you talked a little bit about content generation. So maybe you can share a little bit why is that something that's important for Netflix? What are some of the models that you guys built or projects that you built in this space? And again, I think what's always interesting is how do you measure the success with these things?
Um, okay, so we spend tens of billions of dollars in content creation, right? Like I think $15 billion or so last year. So you can imagine how many TV shows and movies that we release almost on a daily basis with that budget, right? And if you think about content creation, there's a lot of mundane tasks that our creatives needs to do, which is so not creative, right? Take an example of trailer generation. You've seen Mission Impossible, for example, and you want to create a trailer for Mission Impossible. It's a very strenuous task. You, our creatives, look at each scene, try to figure out which scene was worthy enough to be in a trailer, and then they try to. The whole technical process is called breakdown assistant, where they break down the whole video into multiple segments, tag each of those segments, and then be searchable at a later point of time. And then make sure there's a diversity of shots in that. At the same time, you need to make sure that you don't reveal any secrets, so to speak, as part of the trailer. And this is just one part of content creation. And what we're trying to now do is to see if we can leverage machine learning models, which can understand content better and help our creatives to provide some candidate, say, scenes, which we think the model thinks could be worthy enough to be in a trailer. Again, this is not for replacing creatives. This is useful for creatives to be more creative and focus less on the mundane activities. So that's one area of where we've been using machine learning for content creation. Artwork generation is another classic example too. Um, Today, we spend millions of dollars to identify what's the right artwork to generate for different content. Again, if there's like so much, hundreds and thousands of videos in our catalog, doing that in a manual fashion is not going to scale as we grow as well. So rather, can we leverage, what's the frames that are there in a video and see which of them could be candidates for our creatives to then add more touch-ups to that and make it more aesthetic so that our members may like or want to play a particular video. So those are some of the models that we're starting to use for ML for content creation. There's more things on virtual production and things too, like you want to remove some unwanted objects in your scenes. But can we leverage some of those machine learning models that can do these kind of things in an automated fashion rather than, or at least in semi-automated fashion, rather than doing it in a very manual basis?
That's exciting. You definitely have a very large catalog of videos and images you can train massive models on. Probably one of the biggest ones. So very, very exciting. Um, so maybe thank you for sharing. I think it's very helpful to understand a little bit some of the business problems. And one of the things that at least really impressed me, and this is not the first time we're chatting, of course, but like how versed you are with like the business and the specifics and the creators work and what they're actually doing, even though like theoretically you're more on the machine learning platform side. But a lot of our customers that we've seen success with, and generally customers that have seen success with ML, is like that there isn't this disconnect between what the business needs or the end user and then the actual people building the models and the infrastructure. So that was just great to see. So with that in mind, maybe we switch gears a little bit. You guys have been doing machine learning productions for a very, very long time. Could you walk us through a little bit of like kind of start from either side you want, but kind of high level end to end? What does the machine learning platform looks like at Netflix?
Yeah. How much time do we have? But look, let me try and see if I can summarize that. If you take a machine learning pipeline, you typically start with data and features, right? So you need the infrastructure to be able to discover data as simple as possible. But even if I take a step back before I go into the details, what's the success criteria for a machine learning platform team? You are enabling ML practitioners to try out, test, or offline experiments as fast as possible. The time that it takes to from an ideation to productization, that's the key thing that you're trying to optimize for. If your infrastructure is good, the time is obviously much lower. So again, your machine learning models can only be as good as the data that we provide to it. So it's super critical for us to make sure that accessing data, discovering data is as simple as possible. So the first piece of infrastructure that we build within Netflix is data infrastructure for machine learning. The running joke within Netflix data engineers is that Netflix is a logging company that also happens to stream movies. So much of data that gets logged into our data platform and things too, so that we can better understand our members' taste. So the first part is around, as I said, data infrastructure, making sure that we can easily discover data, making sure it's easy to access data, not just in personalization, even for content creation, accessing media data in a much more simpler fashion in a notebook setting. So we leverage notebooks as the core IDE for ML practitioners. And then as you get data, how do you make sure your features are generated in a simple fashion? So how do you standardize features? How do you store them in the right formats that's more efficient for training? And how do you discover features and make sharing more easier across ML domains, not just within a particular domain? And then once that part is done, how do you train things faster? How do you make access to GPUs as simple as possible? I'm sure every company has things to making access to GPUs is not easy because it's more expensive. And once you have GPUs, how do you want to train things in a distributed fashion as simple as possible? And then look at your offline model metrics and be able to see if that experiment is a good or not. So again, essentially, how do you close the loop from offline experimentation to productization and learning from that product as fast as possible, and essentially building tools in each of these different layers, right? Like right from notebooks for offline experimentation to good workflow schedulers to schedule workflows on a regular basis, to building tools to figure out the quality of data in different areas as well, right? From the raw data to your features. And making sure that those features are clean before you train your models, and that the model variant that you just trained today is better than what is already in production, so that you can then turn on that model into production. So those are the different stages, and essentially building tools and infrastructure, all these different stages.
So if you don't mind, this is fascinating. Maybe we can double click. I know there's some things that you guys you solve some really hard problems. I know you talked a little bit about notebooks being the ID. How do you make these features accessible? Let's start with kind of offline training, and we'll figure out how we connect it in production. I'm sure that's not easy. But how do you make these features accessible to like a data scientist that just want to experiment, try different things? What does it look like? Like,
Yeah. All right. So if you think about, okay, I'm going to talk about personalization because I think many people can connect here. What are some of the common signals you think is useful for personalization? Let's make this more conversational heavy things. Um, any guesses? Great. What you watched in the past is a great indication of what you want to watch in the future. We have this a little thing called thumbs up and thumbs down. So thumbs up is a good signal as well. So lots of explicit signals like that, and then there are lots of implicit signals too, like what videos you have not watched is also a great indication of what you like, what you don't like. So providing access to that data first in a simple fashion is the most important thing for making feature generation or feature engineering as simple as possible. You don't want your ML practitioners to know where the data is sitting, right? Like that could be in your big data platform in some iceberg table or Hive tables. You really want a programmatic way to access that data and not worry about where is it stored, in what format is it stored, and things. So if I fire up a notebook, there should be simple APIs to say, oh, get me the watch history data for members of a particular cohorts of members, and then be able to write features or feature definitions on those data and be able to compute that within the notebook environment. So again, things like Spark makes it super easy for us to do distributed data processing. On some of these are embarrassingly parallel. ETL jobs, feature engineering or label engineering in a large ways is ETL. So having access to these kind of libraries and having access to a standard way to create features is also critical. And then once you've done that, having a repository of features and making that easily discoverable is another thing too. Within Netflix, we have something called a fact store. And I know fact is not something that's a very commonly used industry standard term. Think of fact as a raw data using which you can create a machine learning feature, right? For example, what you call as a watch history is a good fact data. These are immutable data. And with our fact store, we snapshot data from various online microservices. So we have a viewing history service or a watch history service, which captures or all the videos that our members watch and is useful for our product as well. What videos you have thumbed up is something that is you can see those videos or thumbed up actions in our app too. So these are typically powered by our microservices, and our fact store snapshots data of these different microservices on a daily basis and be able to then provide ways to do time travel and then be able to compute features for any arbitrary time in the past. So things like that with respect to easier discoverability of data, easier access of data, and be able to do things like time travel makes feature generation a lot more easier at Netflix.
Interesting. So I think one of the things you talked about fact store, but from what I'm hearing, it's actually quite different from a feature store, right?
Yeah.
So you guys provide, but is the platform team providing the computed feature? Is that something the data scientists, they just get raw data and compute it themselves? What does that look like from the user experience?
Yeah. Until recently, we only supported a fact store and then let our ML practitioners generate whatever features that they want to. But over a period of time, as we expanded machine learning across several domains, right? Like now we are into games. I don't know how many people play games. I don't play. Yeah, there's not many games in Netflix yet, but this is an ongoing investment that we started to do in the next few years. But as we again, as I said, as we start to embark machine learning in different domains, we felt it's important to share features across ML domains, not just features, embeddings too. Because it's inherently a time-intensive operation and a resource-intensive operation. So you don't want to reinvent the wheel every time. So a feature store, along with a fact store, is really helping our ML practitioners to cold start new models easily, so that you can look at existing features used from them. At the same time, you can create new features easily with a fact store. Um, Again, many companies also do things like feature logging, which is a very reasonable approach to doing feature generation as well for offline model training. But the problems that we have seen within Netflix for feature logging is that typically you want to train your models for large data sets. And if your training window size is, say, I don't know, say a couple of weeks, for example, then you really have to create a feature, deploy that in production, wait for the data to be collected before you can train. Unless your scale is way too big and you just want to wait for a few hours, you have enough training samples. I don't think Netflix is there at this point of time to that levels. So we feel a combination of a factor and feature store really makes feature engineering much more simpler to do.
Fascinating. Well, I'm curious to hear what does it look like when eventually this model makes it to production. But maybe it will follow kind of how you cover the. So we talked a little bit about the data side, making the data accessible. Let's talk a little bit about training, right? So I'm curious to hear, recommendation engines, and from what I'm hearing, the work you're doing about generative models sounds like very different needs there. So maybe you can talk a little bit, what does training look like for these two different use cases and how do they differ?
Um, Interestingly, they're not that different in some ways. They are, again, I want to also clarify when we say generative AI, at this point of time, we're not building models to create content, and AI generated content is not what you see in our app and things. I just want to clarify that. What we are doing is to leverage, as I said, machine learning for making content creation easier, right? I can't emphasize more that we are not here to replace our creatives, but more for helping our creators be more creative. But in the case of training, what we have seen in cases for ML for content creation is that those models are inherently big. I've seen some folks who are into computer vision here. These models have much larger parameters, models, several millions of parameters, if not billions. And how do you train those models from scratch is slightly different from typical foundational personalization models, which are maybe smaller in size with respect to model, but the data size is humongous. So for both these different types of models, you want to have enabling things like distributed training much more faster to make model training faster. You want to make access to data also faster here. And what I mean by that is, in the case of media data, throughput to your data access is the slowest that we have seen, right?
Mhm.
You may have your fastest GPUs, but if you're not able to optimize the data loading time, your your training time is still slower. So this is where things like, again, we are AWS shop. We have leveraged things like FSX for Lustre from AWS, which has really sped how we can load data into TensorFlows and PyTorch, and leverage GPUs better for some of those use cases. So data loading is slightly different for different use cases in personalization and ML for content creation, because for media data, inherently they are much more bigger. How do you optimize your data loading for these training jobs are different. But then end of the day, everything else relies more on distributed training. Whether you use data parallel or model parallelism is different for different things. Whether it's fully sharded data parallel, or is it model parallelism too? So that's kind of the difference that I see between recommendation models and what we call ML for content creation. And most of that is similar in many cases.
Very similar. Okay. I know we talked a little bit about some because of the low latency requirements and recommendation. It's more of like a JVM stack on some cases where like most of the foundational work is like Python, PyTorch. But that's super helpful. So maybe on the same topic of kind of like the training side of things. Can you talk a little bit about what does like offline training, offline experimentation looks like in Netflix? What tools do you guys use? Is there any difference between like the recommendation and the generative content generation side of things?
Yeah, look, as I said, our team starter or success criteria is about how fast can we do experiments. And Comet has actually helped in some of those cases as well. Like we leverage Comet more for experimentation tracking. When we have our ML practitioners leverage Comet to keep track of what data they use, what kind of model architectures did they use, what was the model metrics for that. Comet provides all of that so that we can easily reproduce what our one ML engineer did for the other engineers. I think that's a pretty good value add for us, leveraging Comet for experimentation tracking. But again, generally speaking, we leverage the same infrastructure that we use for productizing our ML workflows also in experimentation. And in fact, it's important to not have different stacks for offline experimentation and productization, so that we don't run into any new issues around that. But with offline experimentation, as I said, you leverage notebooks more. You want to keep those feature generation and stuff to be as reactive as possible, so that you do in a more iterative fashion. maybe for offline experimentation, you do things like maybe smaller data sets before you train and put it in a pipeline to see how it works at a large scale. So for the most part of offline experimentation, leveraging the same infrastructure that we use for productizing a training pipeline, but leveraging more things like IDEs, like notebooks, and looking more at like offline metrics to really see if the experiment is worth doing an A/B test, right? More often than not, many of the offline experiments don't see the light for doing an A/B test, which is great. A failure is a great learning, more so than an actual success. So you want to see those offline experiments, look at all these offline model metrics, and make that process as iterative as possible.
Thanks for sharing. Super fascinating. So if we kind of walk through, I think we covered data, experimentation, training. Um, And then I think we started the conversation. You talked about like just in the homepage about a few tens of models per user, and I don't know how many of them are personalized model, how many of them are serving the same. But maybe we talk a little bit about like that side, like deployment, serving. And I'm specifically really curious about what does it look like if I'm a data scientist and I built my models using the fact store API and the feature store API, which I know is a newer concept. Like, what does it look like in production? Is it the same code that pulls these features? Is it separate? What does that process look like?
Yeah, great question. Look, it's super critical, especially for personalization models, to not have training serving skew, right? And the way that we ensure there is no training serving skew is that we make sure that the data that we use for inferencing and training is exactly the same. And the code that is used to generate features in online and offline is also exactly the same, right? So when we talk about fact stores, what we essentially do is at the time of inferencing, whatever raw data that you use to create features during inference time is what is logged into the fact store. And then we use that for next day's model training. And at the same time, whatever code that you use to generate features offline is also what we use in the online side of things. So, which is why we leverage things like Scala for offline experimentation and offline feature generation with Spark. And for the online side of things, we are still a JVM heavy shop. As you can imagine, personalization needs to be low latency access to our members, and Java works much better compared to Python for these kind of low latency applications. So leveraging this JVM stack for both offline experimentation and for online serving helps. Did I miss any part of that question?
I think you covered it. Yeah. Maybe no, I think you covered it. So, I mean, I can ask you a million more questions, but just being mindful of time. Obviously, this industry is moving very, very fast. Both MLOps and machine learning in general. What are some of the things that you're mostly excited about and you're following in the industry? And then specifically, do you think any of those things will like impact the media and entertainment industry?
What do you think is the answer? It's a small three-letter word. GPTs. It's fascinating how much this industry has evolved in the last year or so, right? And things like ChatGPT has literally made or democratized machine learning and novel, innovative ML techniques to the common people. As a company on that does things like content creation and for entertainment business, you want to ensure that you are using the latest technologies to help creators create content. With the advent of GPTs or simple like text to images, text to videos is a great advancement in the field. And there are various open source models too, like Clips model, which does these kind of open source text to video. But imagine a place like if you are a creator and you are trying to do things like animation movies, for example. They do spend a lot of time on what should a background look like for an animation movie. And what if you tell your LLMs that, hey, show me a background image with with rainfalls and fantastically rosy flowers and things like that, and maybe it helps them to enhance their vision of their creative process, right? So generative AI is a super exciting area for Netflix to look at and see how can we make our creators more creative. Again, I can't emphasize more. It's a creative process. We don't expect AIs to, at least never say never, but we don't expect it, at least in the foreseeable future, for us to show AI generated content at Netflix. But again, as a creative process, can we make our creators more creative? And maybe these kind of things of, say, a background generation can help our creatives really go into their vision of what do they really want to see in the screen, and how can we make that better, and how can they make that visually more aesthetic. And generative AI is a great place for us to keep an eye on.
Thank you so much, Prasanna. I'm sure a lot of you have questions, so feel free. You can ask and I'll repeat the question so we'll have it on the recording. Go ahead.
So I'm leading the machine platform team at Glassdoor, and something that we struggle with a lot is the build versus buy versus borrow type of question. Like, did that ever happen? Like, do you guys have that conversation? We buy a platform.
Absolutely. In fact, it's critical for any company to look at build versus buy or borrow, as you said, like open source things on a regular basis. In fact, at Netflix, whenever we are trying to invest on a new area, we ask that question: is it more cost efficient for us to maybe buy something or before we build? And we've done that in many different things. Like we leverage open source left and right across our infrastructure. And we've also open source things like Metaflow, which is our one of our core ML frameworks that we have that is open source for a few years now. We also open source a notebook solution called Polynote, which can work well for both Scala and Python side of things. But yes, it's a very important question to ask on a daily basis with the advent of things like SageMaker and GCP's things. Almost everything is now a commodity, right? Like feature stores are table stakes, right? So many feature stores available in the market for both vendor-based supports and for open source as well. But again, what you want to really do is, are those open source ones and vendors really plug and play for your infrastructure, right? And sometimes the answer is yes, sometimes the answer is no. And if the answer is no, try and figure out why and what are the niche things that it's better off building. So long story short, I would imagine we do. I mean, like we do that for any new initiative, and I think it's critical for us to do that. And even if you're building things, just looking at what are the options that's there today will help you be better at what you want to build and what you don't want to build as well. So having that question is super critical.
Yeah, it's working. So question on like something that all ML companies need to do is to have easy to define ETLs and data pipelines for ML practitioners. Um, but when we are talking about very large scale data sets, it can take, or at least in my experience, I've seen it take many hours for that to happen. And sometimes you realize that, oh, like the query was slightly wrong, or this is not exactly the data I was looking for. Maybe it's too generic question, but I'm interested like in terms of how have you solved this problem in which ML practitioner can very efficiently or quickly access large data to train their models on. So yeah, is it just simple application of Spark, and or is it something that Netflix has done differently than other companies?
It's a good question. I'm trying to see what has Netflix done that's unique in the industry. Look, we leverage Spark, we leverage Presto, and other companies. Um, it's true that you may be, executing things for a couple of hours as you access large data sets, and you end up finding that something was bad in your query or something that was bad in your Spark SQL query and things. Um, I think one of the things that we have done reasonably well in the past is doing better at unit testing, right? Like you want to ensure that you're able to execute your queries in a local environment at the first place. You want to ensure that you have some represented copy of the data available in your development environments as well, so that you can run your queries locally to then check if you're able to functionally write the correct ones before you can probably execute that at larger scale. Um, I think that's mostly what we have been doing. I don't think we've done anything unique that has fundamentally changed how can you make that process better. Look, if there's bugs in your query, there's nothing much what the Spark engines or Presto engines can do. But being more disciplined in software engineering, this is at the end of the day, it's a lot of things is general software engineering disciplines. And you need to ensure that you have written good unit tests, written good integration test before doing things at a large scale.
Thank you.
Hello. I just wondering. So when you manage your ML team's training jobs, model training job using the GPU resource, and I know you run your AI infrastructure on AWS Cloud. Cloud is on-demand service, pay as you go. So does it mean any engineer need to run their job and require whatever number of GPU your platform just allow, or you measure a queue, you have a fixed number of GPU. Don't
Good question too. Look, as any AWS users here, there are two concepts. There's reserved capacity and then there is spot capacity. We try and make sure we leverage as much as reserved capacity as possible. So we at Netflix there's a separate team which figures out which does capacity planning, which is super critical, right? You don't want to over invest and reserve too much capacity from AWS and just waste for those resources. So what I'm trying to say is that for things like GPUs, especially when they're super expensive, these are mostly reserved capacities. And we say in advance to AWS if we want to increase our fleet capacity by even if it's like 10% or so, so that we can better manage our cost for that we get billed with AWS. So for the most part, with ML practitioners, when they want to access GPUs, whether it's for training and stuff, those are all going through the reserved capacity and not much on spot capacity. Yes, we have an ability to do that. But again, this goes to our fundamental culture of what we call freedom and responsibility. Our ML practitioners have the freedom to try that out, but then they also have to be responsible for, is it worth the money for doing spot instances as opposed to maybe waiting and scaling it up with reserve capacities.
Okay.
Did that answer your question?
Yes, yes. Also for the training data, you mentioned you need to use the data from maybe from the production users' data. Um, so do you have a kind of we know we have a lot of offline training, right? Collect data training in not in production, but do you need to have a scenario that you need a online retraining the model, which need to access the users' data, but the engineer not able to access the production environment, right? So how do you handle the data from production in users' data, but engineer not able to access that?
Right. Look, first of all, when we do things like offline model training, you want to make sure that you're not hitting the online services, right? Like you don't want to bring down your online services when you're running like high throughput training jobs. So if you remember, that's where we snapshot that data into our fact store, which is essentially in our big data platforms. So at the time of training, you want to access this data from data lakes, like even S3 for that matter, and not hit these online systems. So what we have done within Netflix as the data platform is as user interacts with our app, as I mentioned, there's a lot of data platform infrastructure that was built to log all of the data into our data warehouse. And offline training always looks at the data from the big data warehouse.
Just a follow-up of my previous question again on data access. So let's say the fact store, if it's rawish data, if you are looking at past histories for many days, which most personalization models need to, it is very expensive to compute over long timelines. Do you use some sort of automatic aggregate creation? So to create aggregate tables and then make them available in the fact store so that the job at the time is not super expensive?
Yeah, good question. When I say raw, it's not super raw. You can think of it as transformed raw to a certain extent, right? And yes, there are various transformation job that happens, and we snapshot that transform data as well, so that we don't have to have each ML practitioners do those kind of transformations. So yes, absolutely. You do want to have your ML practitioners reuse those kind of common data transforms and not reinvent the wheel every time.
So I think it's really interesting to hear that there's an undercurrent of model success criteria tracking to business value, which ultimately drives value for your subscribers. How do practitioners stay in line with their business counterparts on aligning what those business metrics are when they're thinking about a modeling task?
Good question. Look, again, as I said, if you look at business metrics for personalization, we talked about like, how much streaming hours are this particular model is enabling, what's the retention that this model is enabling. Again, when we do A/B testing, there is a cohort of users who are experiencing this new model versus what's happening in production. And then we can be able to figure out of those cohorts of members, are they streaming more and are they retaining more, right? So that's the business side of things. But end of the day, for you to stream more, you have to figure out and easily discover the content that you like to watch, right? So that's where personalization model comes into the picture. So from an ML practitioner's perspective, you're optimizing the model to find the next right content or the next content that you want to watch very soon. But at the same time, you don't want to be too focused on short term, right? Like you want to also focus your models on long term benefits and not just focus on short term benefits. For example, if you're watching a particular series, and you say you are in season 2, episode 3, continue watching. Is the first row that we typically show in the Netflix app, because we know that you're in binge watching, so to speak, and you want to actually show that. But if we optimize just for that, you won't be able to discover new content that we think you want to watch after, right? So from an ML practitioner's perspective, it's all about how do we build models that can help our members find the video that they will enjoy as soon as possible. And that kind of correlates reasonably well with our business metrics about streaming hours and retention.
So just as a follow-up, is it fair to say that practitioners are actively looking at these success metrics as they're thinking about initial modeling tasks, retraining tasks, and things of that nature? Or do they find themselves siloed and they're really just thinking about model creation?
No, look, as I said, when models are graduated to do an A/B test, there's a good dashboard that they look at, which looks at those business metrics right in the UIs, where you can see how is the model reacting to, or how is the model attributing to your business metrics. So if they are far away, as what Gideon said, you really can't move your business in a meaningful way. So I think it's important to make sure that they are well aligned with what the business is trying to move forward to.
All right. Prasanna, thank you so much for coming here today. Do you have another question? Yeah, of course.
First of all, thanks for your time. Fascinating to hear the end-to-end pipeline, ML pipeline, and Netflix. I'm a little curious to know about Netflix ML investments towards gaming, like the new stuff. Like, how are you looking at ML's investments towards either content generation or increasing customer engagement, since it's been like a new initiative that's come up in the last few months or like a year or so?
Yeah, look, we're still day zero in gaming. Well, if you're day zero in personalization, imagine where we are in gaming. We have a handful of games launched in our service. At this point of time, what we're really trying to do is to make the discoverability of games more prominent. Like many of our members, many of my own friends or family members don't even know that there's games within Netflix or don't play. So at this point of time, it's more about personalizing those things. For example, we have a game that on Stranger Things. So if you are a Stranger Things fan, you need to maybe show that game more prominently for members who stream Stranger Things or stream videos that are related to Stranger Things. So we're not at a place where we're thinking about leveraging machine learning for game creations and things, but it's more about how do we make personalization of games more better, especially as we launch more games in the next several years. It then becomes similar to videos. There'll be a lot more games, and how do you personalize the right games to the right members will be a good challenge.
All right, Prasanna, thank you again so much for coming here today and sharing your knowledge with us. I know I've learned a lot, and really, really fascinating to hear, even though, I've known you for a few years and heard every time we chat, I learn something new about your approach to the platform team to solving these really, really difficult engineering problems. So thank you again for sharing your knowledge with us.
Thank you for having me. I think great conversations as well. Thanks for some intriguing questions as well. So I enjoyed my time as well.